Hi everyone, my name is Joel and I'm going to present my CS50 final project. Well, I did a terminal raycasting. To explain what is that and how it works, I'm going to explain first what is the map of this game. Here I have a map that is a file, but is going to be imported to my program. Well, the map is basically a b-dimensional matrix where the ones represent walls where the player cannot walk and the zeros represent empty spaces where the player can walk. To show a little example of how it works in a 2D representation of my game, here I have. So this is the map that I show you before, and here's the player where it can walk in the map, and we can see that they is doing some lines that is actually race. Well, this race is basically calculating the distance between the player position and the first occurrence of a wall in his direction. So for example, the player is here and it is a ray. So the ray does your route until find a wall, and when it hits a wall, he stop and calculate the distance that was done. Okay, this algorithm is made in every ray that is in the player doing this result. But it's interesting to see that the ray cannot pass through walls, so when it find a wall, it not go through it. So in this example, the ray goes here and not shows behind the walls, and this is important because the player cannot view what is behind the walls, just what in front of it. But now I'm going to explain how this calculation of ray distance can project a 3D plane of my map. So when we calculate the length of each ray, we can get a way to know how big is going to be the wall drawn in the screen. So when a ray has a longer length, like in this example, it's going to give a very high length, so the computing is going to result in a small wall drawn in the screen, because far away things are looked small in our field of view, but otherwise the closest walls is gonna be drawn bigger, because closest things in the field of view is look bigger. Okay, to show how it works in practice, I'm gonna present now the 3D projection of the map. So let's go. Okay, so now we can see that when you get close, we can see the walls get bigger, and when we go back, the walls get smaller. And that is the way of get the perspective of things that are far away and things that are closed, giving an 3D impression. Okay, now that was understood, I'm gonna explain the coloring concept. So we can see that the far away walls are darker with the shadow. It happens because things far away are normally darker, and closest are lighter, with more light. Yeah. But the thing is that in terminal we can put like colors, and to represent that I'm using characters. So to do the color, I use just a escape character, that is the -E, that can put colorful characters in the terminal. But to do the shadow and the lightning, I'm using the density of each character. So I'm gonna get close for my terminal, and we can actually see that it's just characters. But his density calls an impression of more light or less light or shadow. So in this example, the faraway wall is just is representing by points that has less density and produce less light. Okay, finally I'm gonna show a complex map that I did and can be rendered in my program. Okay, so now we can see the same concept working. We can see that the faraway walls are drawn smaller and the closest are bigger. And the coloring, we can go there. It's a room. And this is actually just characters, and that is it. My final project, terminal raycasting.